Good evening, friends. Okay, so let us solve one more problem. And this is hybrid motion. I'll tell you why it is called as hybrid. Okay, so a body is allowed to fall from a height of 100 meters. So you have the cursor. Oh my God. You have an object. This is the ground. So you're allowing it to fall by a height of 100 meters. This height is 100 meters. After 2 seconds, its acceleration due to gravity vanishes. Now this is coming down, maybe at a certain height. Okay, the time taken by the body to reach this height. Let us say this is point A, this is point B. It has taken 2 seconds. Taken 2 seconds. Then the gravity vanishes, which means there's no gravity after this. Then the total time of fall is. How much more time does it take to reach the ground? So here definitely there is an acceleration due to gravity. But here we do not know. The acceleration due to gravity vanishes. Now how much time more will it take to reach the ground? This is the question. Now how do we solve this? Let me label it like this. So again, a blind intuition. As I already told you in the previous video also, given any physics numerical with some data, very, very important, with some data, see to it that the solution lies in you working out and not just guessing something. Here it's an open guess. So the students gave me the option B as the right one. The reason they thought, what is option B? It slows down and starts floating. Why does the object fall to the ground? Simple, gravity. Gravity pulls it. So because of the gravitational force, it keeps on coming down. When gravity vanishes, what should happen? It should slow down, right? Why slow down? Because no gravity. When no gravity, what will happen? They thought, remember, this is one thing which I got. They thought that there is air resistance. They assumed that the particle is a parachute. It keeps on coming down, and at some time there's an air resistance given. Have I mentioned anything here? If I have not mentioned, you should not assume, right? It's a mistake people do. Okay, and then they think it starts floating. It's not a kite to keep on floating. When it had a mass here and it started to fall under the gravitational field, 100 meters it has fallen down. Now it has to fall, not 100 meters, it has fallen down for 2 seconds. Then suddenly when gravity vanished, why should it float? People did not think about it. Now let us see how do we solve this. The first one is, what kind of problem is this? This problem here, from here to here, there is no other force acting on the particle. Hence, this is free fall. Free fall. When I say free fall, you can also say this is constant acceleration. And there's no wind, there's no air resistance, nothing I have given you. Then, secondly, when the gravity becomes zero, at this point your gravity becomes zero. Now what will happen? When the particle reached at this point, what was its velocity? Did it slow down? It never slowed down. It was increasing its speed. And finally, when it reached here, it had some speed. Now, what is this speed? If I ask you, how do you do this? You do it by using your formula, y equal to u plus at. You dropped here, so u was 0. And a, this is one more. Students generally put a equal to minus g. Okay, and suddenly they get v equal to minus gt. Okay, so now what we do is 0 minus a is equal to minus g, and t. What is t here? 2 seconds. Until 2 seconds, there was a gravity. And at the 2 second, the gravity immediately vanished. Why? I don't know. It's a physics problem. So there are some assumptions. So therefore, this value will be equal to minus 2g. If I take the value of g to be 10 over here, this is minus 20 meter per second. Hey, look at this. Velocity is negative. How can velocity be negative? What do you mean by velocity becoming negative? That means the particle is moving in a downward direction, right? So when the particle approached at this point, the particle's velocity is saying to be minus 20 meter per second, or it is moving downwards. Now, if there is an acceleration, the speed of this particle, which is 20 meter per second, would have increased. When there is no acceleration, what is acceleration? You apply some force constantly so that the speed of the particle keeps on changing, keeps on increasing, right? And if there is no acceleration, which means what? There is no gravity at all. There's no gravitational force at all. But this already has a velocity. And hence, this will start moving with the same velocity and reaches the ground. So when it reaches the ground also, it has the same velocity here. Which means in this region, it moves with an uniform velocity. Uniform velocity, right? So towards it. Now, first thing is what is being asked over here? He is asking you, find the total time of fall. He wants this time. This time, let me call this T2. This time is T1, which is equal to 2 seconds. So we need to find out the value of T2. Now, how do you find the value of T2? It's a bigger question. Simple. If I know this distance, since the velocity is known, okay, remember always, whenever uniform velocity motion is discussed, so you have only one equation to solve. What is that equation? The equation is S equal to V times T2. The value of V is already given to you, 20. Substitute that. 20 into T2. If you know the value of S2 here, which S2, what is S2? BC, the distance BC, you can easily do it. But I don't know that. Now, how do we get that? Okay. So now, so towards it, do I know the value of AB? At least if I know the value of AB, I can say BC is equal to total length, 100 meters minus AB, right? I can write BC is equal to 100 minus AB. I can mention this. But how do I get the value of AB? That's the biggest question. Now, you dropped a particle, it reached here in 2 seconds, which means you can find AB is equal to 0 plus half into, what's the value of G? G is nothing but 10. And how much time? 2 seconds. 4. So this should be 20 meters. So this distance is 20 meters. Then what is BC? BC should be 80 meters. 80 meters. Now take this value, put over here. Okay, what is BC now? S2 here, right? So therefore, this implies, now you put 80 is equal to, what is V? 20 into T2. Why 80 here? Because this S2 is this distance, right? I'm not going to put 100 over here. I'm going to find out only this one. 80 equal to 20 into T2. T2 is equal to 4 seconds. But some of them have even marked this one, which is also incorrect. Because they got some value over here, they put it. But what you need to do, you need to add this T1, which is the time taken by the object to start from here and to reach point B. And then T2, which is nothing but B to C distance, B to C timings. Thus the total time taken should be T1 plus T2, which should be 6 seconds. Thus the answer is T. Children, hope that this video is informative. It helped you a lot. Thank you for watching this video. Like, share, comment, and subscribe to my channel for further updates. Thank you.